I'd like to add one more bit of optimization to our fixed interior pieces. In the last video, I mentioned that we don't need to keep all these tiny little pieces in there. We will have some pretty small pieces in our final fracture, but we don't need all these little bits at this stage. So let's delete those based on their size. Now I have an existing measure fracture HDA. I won't go through how to set up an HDA all over again since we just went over that quite a bit in week 1. But I will show you how I set up the parameters on this. So I'll right click that and go to Type Properties. And we'll go to our parameter list here. And I've set up checkboxes for the bounding box size, area, and volume. These checkboxes are linked to switches inside that you'll see in a moment, and the same way that we set them up in week 1. But I've also added this size filter menu here. I've added these options for that menu in the menu tab, so you can select none for no size filtering, or bounding box, or area, or volume. And then, when one of these is selected in that drop-down, that enables this size threshold. This parameter enabling and disabling is very helpful, especially if your HDA might be used by other people. And if you go back to the parameter specification here, there's this disable when field. And I've set that to disable the size threshold whenever this size filter menu is set to 0. So the syntax can be a little bit weird for these disable when options, but you can enter this size filter space double equals space 0 wrapped in curly braces. And once you've set up those parameters for yourself, and we can dive inside and implement these various measures. Now, I built this tool a while ago, and the latest version of Houdini has a nicely updated measure SOP with some features that weren't available before, so it's actually a good thing for me to be updating this now. I will allow editing of contents and dive inside, and we'll take a look at how this is set up. We have a switch for measuring the area. So if that checkbox is not checked, it will return a value of 0, which means it'll just grab our input as is. And if it's checked, it returns that value of 1, which will evaluate this loop to measure the area of each piece. However, we don't really need to run this in a loop anymore. The latest version of the measure SOP has that functionality built in, which is really nice. So if you create a measure SOP, that will default to measuring the area, and you can use this accumulate option, set it to per piece, set the piece attribute to name, and then this will accumulate the overall surface area of each piece based on that name attribute. I'm sure it does some sort of internal looping that's similar to what I've done manually. And checking the spreadsheet, sure enough, you can see those consistent area values for each piece attribute. So I'm just going to grab the second input of the switch, attach that to our new measure node. I'll call that measure area. We can delete the old loop version, and that's much nicer and cleaner. We can do the same thing for measuring the volume. Drop in another measure SOP. This time we'll set the measure parameter to volume. Once again, we'll set that to accumulate per piece based on name, and we'll connect that to our measure area output, and we'll connect our switch for the volume measure to our new measure node here. Delete this looping thing, and then I'll just call this measure volume. So much cleaner than the old technique. Now the B-box measurement is a bit of a special case. I'll disconnect this loop here and delete that, and we'll set this up from scratch. We did set up a B-box measurement previously per piece. If you remember, we used that per piece B-box size to determine which were the floors versus walls, based on the bbox y height. But in this case, we don't want the XYZ bbox information. We want the overall volume of the bbox. So if we go back inside our measure fracture, we're going to set up another loop. Once again, we'll loop for each named primitive, and we'll connect that into our switch. And then within this loop here, we'll create a new wrangle node. We'll make that a primitive wrangle. And then let's create a local variable vector called bbox. And similar to before, we'll say that equals get bbox size of input 0. But then, to get the volume of the bbox, we'll say f at bbox size is equal to bbox.x times bbox.y times bbox.z. I'll rename that wrangle, let's call it bbox size. And let's check our spreadsheet at the end to make sure that looks reasonable. And you can see we do have this bbox attribute in here. This might be a little bit confusing because you could say, hey, we're not creating a bbox attribute, but that's what we created earlier in our setup. So you can see that coming out of the merge node, we have this bbox vector existing on the geometry. So that's what we're seeing on the spreadsheet for the result after measuring the bbox size. But if you ignore that bbox vector there, you can see that this bbox size is correctly accumulating a per piece volume of the bounding box. Now, I usually use the bbox size instead of area or volume. They're all pretty similar, but the bbox size is likely faster to compute because it's easy for Houdini to tell the size of a bounding box, and it doesn't have to actually calculate and compute the per primitive area and volume and then sum that all together. And on this geometry, it's pretty fast to do any of those, but with some really heavy geometry, you'll probably notice a big difference when just using the bbox size instead. The other advantage of using the bbox size is that this will also work on packed geometry, whereas I don't think that the measure volume and measure area would work on the packed geo. You'd probably have to unpack them in order to use those. But in any case, it's still nice to have all three as options, especially since it's relatively easy to set up all those options as an HDA. Now finally, I'll set up that size filtering. Let me just delete these filters that I have existing now, and I'll disconnect those two outputs. And if we jump out of this measure fracture HDA, I'm going to pin it to this parameter view here. That'll make it a bit easier to copy relative references down inside. So then we'll go back inside our HDA and we'll create a switch for that size filtering. And previously we've created switches that are relative referenced to checkboxes, so it just chooses between two different inputs. But you can use multiple different inputs to the switch, not just limited to two. So if you copy this size filter, go to copy parameter, and paste that relative reference into our switch SOP. So you can hit P to bring up the parameters down in the network view here in this floating window. So I'll paste the relative reference in there. And if you middle click, you can see this is currently selecting input number 1. Now that's based on the menu that we've set up in the properties of that HDA. If you go to that size filter, I already pointed out that this menu has a few different options. You can choose no filtering or one of the attributes to filter by. But this token is the actual value returned when you query this parameter. These labels are used as what you see in the UI, but it's going to actually return 0, 1, 2, or 3. And you can change this in these fields here. So since that just returns 0, 1, 2, or 3, that makes it easy to set up a few different options that it selects between in the switch. Now we can close that parameter view there. You can also get rid of that spreadsheet. Now option number 0 is no filtering. So in that case, we can just grab the output of our measurements down to the switch here. And then option number 1 is the bounding box. So let's set up a bounding box size filter. So drop in a split SOP and we'll connect our measured geometry to that. And in that group, type at bbox size is less than, and then copy the size threshold and paste the relative reference into that group. So it says bbox size is less than that size threshold. Now if you display that size filter, you can see that some pieces are getting filtered out, but this size threshold of 10 is not working very well for this case. So if you lower that size threshold to, let's say, 0.1, you can see that's isolating all the small pieces. Now we're going to use both outputs of the split, so we can make a couple copies of our switch that selects between the different types of filtering. We can perhaps make a copy of this, filter type small, and let's duplicate that and call this one switch filter type large. And we can rename the split so that our scene makes sense to split based on bbox size, with the first input going to the small and the second input going to the large. Now let's copy our split SOP and we'll make area and volume variants of this. So you can rename that to split area, and instead of setting that group based on the bbox size, just change bbox size to area. And once again, we'll connect that to the filter type small and filter type large. And we'll make one more copy of this for the volume and name it as such, and change that attribute that it's using and the group to volume. And we'll connect that to both of these switches as well. And then finally, this switch for the small pieces will go to output 0, and the large pieces will go to output 1. So now that this is all set up, we can jump out of that tool there. Let's save the node type and tell it to match current definition. And I'll turn off the area and volume. We'll use that bounding box filter, and it looked like that size threshold of 0.1 is working pretty well. When you display a node with multiple outputs, it'll only show you the first output. And I actually like working with the measure fracture in this way, such that it displays the small pieces that I'm calling out, but then I'll just connect the second output downstream if I want to keep the big ones. This is just a convenient way of easily viewing what you're removing from your geometry while passing on the rest of it. Now we're going to recalculate these sizes once we do a nice detailed fracture on the geometry, so we're not going to need to keep this attribute around right now. I'm just going to go to this attribute delete and add that bbox size there to clean it up. Now as one last little step, I'll connect my exploded view to that second output of the measure fracture just to see if there are any little pieces that aren't being caught by our filter size threshold. And it looks like we're pretty good. If you want to, you can expand that exploded view a bit. Maybe scale this out twice as much so it's a little easier to see. And it looks like, yeah, that value of 0.1 is working quite well. And this interior section of geometry is finally ready to be fractured.